Okay, so go to Google and type Art Explorer. Okay, uh, click enter, and you will get to this web page. So Art Explorer, this is the your user interface of Art Explorer. And now one thing you need to keep in mind that if you are first time visitor of this website, you must have one login password or user ID. So you have to sign up for this website. If not, you already have user ID and password login credentials, then just log into the website, and here you will have the images, and in left side you will get all the different search criteria. Now so in this search criteria, it's already some previous things are there, so I will just clear coordinates. Okay, uh, now from here we have two different ways of selecting our areas of interest. One is if you go to the address and place, okay, and other is path and row. If you know the path and row of a area, then you can put directly. Suppose I know that in Nagaon area we need 136 path and 42 is the row. So if I put so, then automatically it will show that area. The another way of doing is that you can type address. For example, I put Guwahati. So it's already, this part is already in my uh, computer already saved. So that's why I am getting this face. Otherwise, I could have been showing some different places of the world. So if you show this one, then automatically you will get the address and latitude longitude, and click here, then it will show you your areas of interest. So now whatever may be your areas of interest, you next you need to do search criteria. There are some other search criteria, that is for example date range. uh, anybody's so date range is you have to give. Now here I would like to put 2020 December 1 and January 21 31. So why I am putting this that range? Because one thing we keep in mind that for Northeast India, if we select data from April, May, June, July, August, September, these areas, there is a lot of possibility that we will get cloud covered images. So those are actually no use for our remote sensing processes. Therefore, we should avoid those cloud covered images and preferably go for October, November, December and January, February is the winter months, so that we have a cloud free images. So this is our date range, and we must set the cloud cover at minimum, probably below 10% if we so once we have selected this thing, then we select the data sets. These are the different data available for our study, and I have selected the Lancet 1, Lancet 8 OLI data. So these are the level 1 and level 2 data. For this different description, you can go to the description of Lancet data in the website, the Lancet website. For example, this is Lancet data collection level 1 product definition. So if you click here, you will get a PDF file like this. So here all descriptions are there. What are the different terrain conditions or processing levels, and there are many important important informations are documented here. Documented here, so that we can, and these informations are very much useful for later processing. When we do atmospheric correction and other radiometric correction, we need those kind of information. Now we we selected all these parameters. We have then area of interest. Now go for results. Once you go for results, now you see that these are the different areas, or these are the images selected for our areas of interest. For example, um, 3 images are selected within these 2 months, and based on our criteria, because we set a very low cloud cover, that is why we got only 3 images. Otherwise, if we put it 40, maybe we'll get lot more images. Now if we click this image, it will give you some kind of preview of that particular image. Now once you see this image, you can select one by one. Each of you preview that, and you have an idea of the coverage of your area. For example, you are working in some Nagaon district, whether your image will be covering or not, whether you need another image. So you have to decide based on that. So once you finalize that, okay, so uh, out of these three, it looks that this image is little better, the quality of image is better. So here also you can see the here also you can see the image, um, and preview your coverage over the map. So it will give you an idea that which area within the Assam the image is covering. So maybe if you are working on Western Assam, another map on the left hand side, another image on the left hand side will need your to cover the entire Western Assam. Now, so that means that 3 or 4 Lancet tiler is necessary to cover whole Assam. Now you, once you are finalized, then you go for this link, download options. You click here, and these are the product bundles. You click again, and this is the whole file you need to download. The now you see the amount of file you need, 1.1 GB. That means it's a very big file, and if your internet speed is not very good, it will take. And what I am doing, I am going to teach you here. Basically, you can do same thing not only with the Lancet OLI, but you can do with Lancet TM and Lancet ETM data. You search those things, and why I am asking you to do it Lancet TM or ETM, then in that case your file size will be very small. You can download maybe 200 MB or 300 MB file for Lancet ETM or TM data. In that case, you can download quickly, but the process will be same for all data. This whatever we are learning, that can be applied to any kind of data or any satellite. So one thing you need to know, that different product information. So you download that file. Once you click here, uh, it will be automatically downloaded. But since it will take time, I will not download it now. I have already downloaded it in my folder. So I will show you after that what we need to do after downloading. Now you can see this part. Okay, this is very important. This is about the different I have already told in your theory class probably, and that this is about the information of your satellite. This is Lancet 8, then this is a sensor, then 13642 path and row. This is a date of acquisition. Okay, so this is the date of processing, and this is a tier 1 product. Okay, so it gives you the about description about your product. So you download that. Once you download it, it will be downloaded in a zip file like this. Okay, so I will go to the uh, by default it will come to the downloaded file, but I have put it in C drive, training ArcGIS. Okay, then downloaded image. Now this is the image I have downloaded. So downloaded means it will come like this, zip images. So you have to unzip that image, extract to you have to extract that file. So I have extracted that file, and after extracting it becomes like this. It comes is a open folder. So then you open that folder. Now you see that these are the individual different bands: 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the different, and this 10 and 11 are basically thermal bands. So you from 1 to 9, these are the bands you need. Now again, for our purpose, actually we don't require 9. This is a cloud data. Then 8 is the panchromatic data. Again, this is a different spatial resolution. So we don't require panchromatic right now for composite band. So we require band 1 to 3. Again, band 1 is coastal erosion data. You can avoid, but to have you can keep it in the composite and may not use in your analysis. So in order to do the composite of, because individually if we see this band individually, we can add that. This is the ArcGIS, so in ArcGIS we can these are the toolbox. This is maneuver, probably you have already used. This is table of contents, where if you add something, you can you will see that files here. Okay, so I want to add one file, downloaded image from here. This is the different band. Now band 1, suppose I have added band 1. Now you see this is the complete gray color image, one band. We cannot put it in RGB, red, green, or so only in it is very difficult to process that data. So therefore, and we have a limited information. So this is band 1. That means it has only coastal erosion or that much of data. Many other information are not stored in this image. Therefore, what we need to do, we can add one by one all other image bands. 3, if you select one, then if you put control, press control, then 1, 2, 3, and probably 7. You add all different bands. Okay, you have added those bands. Now in order to make a composite of this, what we need to do in your so in customize extension, you check that your spatial analysis is checked. This you must check the spatial analysis extension. Okay, so then you go to Windows and image analysis. Okay, so these are the different bands. We want to make a single file out of these 7 different files. Okay, so what we need to do, we have to press composite band. Okay, once you press this, it will start working on preparing the composite bands. So let's now you see your composite band is added. So from out of these 7 bands, you have created one single file, but this file is not permanent file. If you close this the software, automatically it will remove. So therefore you have to export this data export data. Okay, so export data. In this table you have to keep in mind that extent is raster data original extent. You have to keep original extent. Special reference, that is your original data set. Cell size is 30 for lens size. We know that 30 meter by 30 meter resolution. And then where you want to put your output. Okay, you put output and give a name of within that output. So I put that this is test 1 TIFF. Okay, form A, and you keep the format. These are the different format, but you keep it as TIFF. Okay, so these are the different procedures. So once you do this, you can click save, but it will take time. Okay, so instead of doing this, what I will do, I have already converted this data to TIFF format. I will open that in my website. So you know that what I did, I open again. I am repeating this thing, image analysis, and from we have selected all these different files. Okay, and then click on composite band. Then automatically it created a composite image, and to make it permanent we have to export this data. Export data. Okay, so you have to create one output folder where you put all your output data. So export data, and you finally, after exporting in a TIFF format, export data, it will create like this. And one thing you remember, you always keep it either in TIFF or IMG format, imagine image, but TIFF is far better. So most of the time we will be using TIFF. So keep it in TIFF and click save. So automatically it will save in a TIFF format. So all file now, what you don't require the other file. So you open the TIFF format. I have put the out within output. So this is TIFF 2. Okay, now you remove the other files. So now we put this in a false color composite. Now here you need to keep in mind that in ETM and TM your infrared is 4 band. 4 band is near infrared. Now here in Landsat 8 your 5 band is infrared. So you have to put 5 band infrared in red, blue in green, and green in RGB. So accordingly you will get this type of false color. So now you see that it will give a the basic raw image. You can now see the different bands, and here you have, if you see the symbology, if you double click on the file name, it will layer properties, it will open the layer properties, and here you will get different bands. Now here 7 bands are there, so we have make a composite of 7 bands. Now you see that this is a 30 meter by 30 meter resolution image. So in that image many times these are not, you see the roads, if you're trying to digitize the roads, these are not very distinct. We can, for digitizing and visualization purpose, we can develop this image by pen sharpening. We call it pen sharpening. So how we do pen sharpening? Now we are going to do the pen sharpening of this image. That means, do you know, we are doing enhancement, image enhancement. Especially the special purpose students, I have already talked about image enhancement. So these are the raw images. Now we are going to enhance the image so that it can be visualized better. So one of the image enhancement technique is the pen sharpening. So in pen sharpening method, if you click here full extent, it will give you the full image, the full coverage of the image. Now again go to the data management tools, then raster, then raster processing. You remember, data management tools, raster processing, then create pen sharpen raster dataset. Now it will open a create pen sharpen raster dataset. Okay, so you just input the original file, so TIFF2, and by default your false color composite files will be added here, but if you not, then you can select and add, and then you have output folder. By default it's created in, but this is not your output folder, so you give in output folder a pen sharp 2, pen sharp 2. I have given name is a pen sharp 2. Okay, so your panchromatic image is there. Again you have to go back to your original folder, downloaded image. This is your image file, and band 8 is your panchromatic image, and the other things you keep it pen sharpening type. These are different methods, but you will keep SRI method, and then finally you keep OK. Again pen sharpening here also, it's a very time consuming because our laptop is RAM is limited. I have only 4 GB RAM, so it will take, and 1 GB data processing, it will take time. Therefore what I have done, again I have that pen sharpening image already. So but now you just keep in mind the process. What I have done, I click from the arc toolbox. This is, I am repeating again, data management tools, then raster, then raster processing, then create pen sharpening raster dataset. Then you just add this last file, that is composite band, your exported file in TIFF file. Don't use the composite file but TIFF file, and then these are automatically given your channels. Then you have to keep a proper name in the output file, and then your pen sharpening bands. Which band is your pen sharpening band? That is your band 8 is panchromatic band, so you have to add that and click OK. So once you okay, it will create your pen sharpening file in the your output folder. Okay, so it will result like so. This is pen sharpen data. Okay, so this is your final pen. Now if you zoom one region, suppose I put okay, I will zoom some region. Okay, this is the original TIFF file, and I have pen sharpening image below. Below is the pen sharpening image, enhanced image, and above is original file. Now I will do a effects, create one effects, that is now you see below it will be more clearer, especially the information. Now you see here in this part, you will see this is the edge is not very clear, but below in the pen sharpen image the image become more clear and it become identifiable. So it's now especially the agricultural fields, you see these are become more clear and sharp, edges become sharp. Now uh, TIFF2, if you go to the properties of the TIFF file, uh, source, go to source, and then cell size is 30 by 30. Your cell size is 30 by 30. But in your pen sharpening image, go to the property, your cell size is 15 meter by 15 meter. That means we have enhanced the spatial resolution of the quality from 30 meter to 15 meters. We infuse the panchromatic data in the Landsat 30 meter resolution data. Thereby, now if we use this panchromatic data, so instead of the original data, what we will do, we'll use this panchromatic data. So these are the panchromatic data, and you see the TIFF data, original data here, and if you remove then a panchromatic data. So urban features become more prominent in your panchromatic data. So for digitization purpose,